The mystery of an ancient star. Could the universe be older than we thought? For thousands of years, human beings have gazed at the stars. From early civilizations using constellations for navigation and mythology, to modern astronomers studying the cosmos through powerful telescopes, our fascination with the night sky has only grown deeper. At the heart of this curiosity lies one question: where did everything come from? In the 20th century, scientists proposed one of the most influential theories in physics and cosmology, the Big Bang theory. This model describes the universe as having originated from a singular point, a moment of rapid expansion approximately 13.8 billion years ago. From that explosion of space and time came everything we know: matter, energy, galaxies, and even time itself. But despite its strengths, the Big Bang theory doesn't explain everything. It still leaves us with major mysteries. What came before the Big Bang? Why did the universe expand the way it did? And, most puzzling of all, how do we explain objects that seem older than the universe itself? In 2023, the scientific world was shaken by a surprising discovery. NASA's James Webb Space Telescope, JWST, observed ancient celestial bodies, stars and galaxies that appeared to be older than the age of the universe. Among these findings is a star that has come to symbolize this cosmic puzzle. Its name is HD 140283, but scientists often call it Methuselah, a reference to the oldest man in the Bible, who was said to live 969 years. This star, located about 200 light-years from Earth in the direction of the constellation Libra, has captured global attention not because it's bright or massive but because it might be too old to exist according to our current understanding of cosmology. Methuselah is also moving through space at an incredible speed, approximately 44,283 kilometers per hour. This high velocity hints at a dramatic history. Astronomers believe that around 1 billion years ago, the Milky Way galaxy merged with a smaller, dwarf galaxy. Methuselah may have been part of that ancient galactic collision, making it one of the earliest witnesses to the universe's formation. What's truly mind-blowing is its age estimate. Early calculations suggested that Methuselah was around 16 billion years old. That would make it older than the universe itself, which we estimate to be only 13.8 billion years old. How is that even possible? More recent and refined estimates place the star's age at 14.46 billion years, with a margin of error of plus or minus 800 million years. Even at its youngest, that still brushes right up against or exceeds the age of the universe. And that raises a serious cosmological paradox. So how do scientists calculate the age of a star like Methuselah? It's not an easy task. Stars can maintain their temperature, color, and size for billions of years, making them incredibly difficult to age precisely. Astronomers use a method called gyrochronology, which involves measuring a star's rotation rate. Like a spinning top slowing down over time, stars also lose rotational speed as they age. By comparing Methuselah's rotation and other properties like its brightness and elemental composition with models of stellar evolution, scientists can estimate its age. Methuselah contains very few heavy elements, which also suggests it formed in the early universe, long before supernovae had enriched the cosmos with metals. So if this star really is that old, are we wrong about the star's age, or are we wrong about the age of the universe itself? That's the question we'll explore next. Stay with us as we dive deeper into this cosmic riddle. Is the universe actually 26.7 billion years old? And what it means for everything. In recent research led by Dr. Rajendra Gupta, a physicist at the University of Ottawa, a bold theory was proposed. What if the universe isn't 13.8 billion years old, but actually 26.7 billion years old? This might sound outrageous at first, but it's based on a new hybrid interpretation of the cosmic redshift, the key evidence used to measure the expansion of the universe. Let's break that down. As the universe expands, the light from distant stars and galaxies stretches. This phenomenon is called redshift, because the light shifts toward the red end of the spectrum. The more redshifted the light is, the further away and therefore older the object is. But Gupta revisits an old concept called the tired light theory, first proposed in 1929 by astronomer Fritz Zwicky. According to this theory, light loses energy as it travels vast distances, not necessarily due to the expansion of the universe, but through an unknown mechanism. Although the tired light idea was dismissed decades ago, Gupta suggests that if we combine it with expansion rather than viewing them as opposites, we get a new model that could explain why we see stars and galaxies that look too old. But there's more. Gupta also incorporates ideas from Paul Dirac, a legendary theoretical physicist who suggested that the constants of nature, like the speed of light or the strength of gravity, might change over time. In Gupta's model, even atomic interactions could have evolved throughout cosmic history. This could mean that our current measurements of age and distance might be misleading, because they assume the laws of physics have always been the same. Could this help explain Methuselah's age? Could it solve the riddle of why galaxies observed by the James Webb Telescope appear mature and structured even though they should be from the very early universe? It's possible. And while Gupta's model is still under scrutiny and debate, it offers an exciting alternative that could push science forward. Remember, this isn't the first time our estimates about the universe have changed. In the 1920s, Edwin Hubble thought the universe was only 2 billion years old. That estimate clearly clashed with the known age of Earth itself, and over time, new methods and observations led us to our current figure of 13.8 billion years. So, a revision wouldn't be entirely unprecedented. It would just be another chapter in the ongoing search for truth. And speaking of puzzles, there are even more mysteries closer to home, in our own Milky Way galaxy. Thanks to the Gaia satellite, which is tracking over 2 billion stars, astronomers have discovered that stars on the outer edges of our galaxy are moving much slower than expected. This could mean one of two things. Either the Milky Way contains far less dark matter than previously thought, or our very understanding of what dark matter is may be flawed. New estimates suggest the total mass of our galaxy is around 200 billion times the mass of our Sun, which is roughly 5 times less than earlier models predicted. That's a huge difference, and it means we might need to revise our theories about galactic structure and invisible mass. Conclusion: from mysterious stars that challenge the timeline of creation, to bold new theories that double the age of the universe, and galaxies that refuse to behave the way we expect, one thing is clear. We've only just begun to understand the cosmos. Science doesn't have all the answers yet. But every discovery brings us closer. And sometimes, a contradiction isn't a failure, it's an invitation to look deeper. If you're as fascinated by space and time as we are, don't forget to like this video, subscribe to our channel, and turn on the notification bell so you never miss another journey into the mysteries of the universe. Thank you for watching. And until next time, keep looking up. The universe is full of surprises.